It's space weather! Looking at the sun in 193 angstroms. Starting out across the room because of volume requirements. Got an active region rotating through the Earth-facing region. A coronal hole which has yet to magnetically connect to the Earth. Not so convinced it's going to. A new coronal hole rotating in near the South Pole. And asymmetry at the North Pole coronal hole continues. Also, there is a filament going on there. Watch the progression of that. Looks like a pretty serious dance going on over there. And let's look at some other views. Looks like we got some filamentary activity in the northwest, southwest, northeast, even the southeast. It's a big filament. It looks like it crashed back down onto the sun. This one up here. It might still be out there. Yep, that one's still doing something. And let's look at the North Pole to see if there are any crown prominences. There actually do appear to be some minor crown prominences. And here are the magnetic lines at 171 angstroms. Again, I'd note the way the South Pole coronal hole looks. Pretty symmetrical there. Versus the North Pole coronal hole. Quite offset. Shout out to spaceweather.com. The site where I first began studying the sun, really. Besides in astronomy class and physics class. Solar wind 449 protons per second, kilometers per second. Solar wind density 7.2 protons per cubic centimeter. 0 sunspots. And the radio flux has now dropped to 70. So we'll be keeping an eye on that. And now let's look at the thermosphere climate index for those of you who aren't familiar. And I guess it's not found. Alright, we'll just talk about the thermosphere index on a later episode. Next we'll head to spaceweathernews.com. See a flatlined X-ray flux. Some spikes in the BTBZ recently, but nothing too extravagant there. Magnetometer is entering into more of a smooth phase here. KP index is back up to 2. Cygnet's forecast has been updated. We'll let that play through. This is up to the 16th. I would note the Parker Solar Probe making its way to the sun for its second run. We got a decrease in the electron flux here, probably associated with that slight increase in the solar wind speed and density. No charging hazards to speak of. And the F2 layer is looking pretty anomalous here, actually. Now, the charged area down here in the southern portion isn't as charged as it's been last week. But this spot here is pretty discharged, and this spot here is pretty charged. So we're going to have a charge disparity, nothing too extreme. Next, let's look at the Gong 2. And we'll see that it looks like we're going to have smooth magnetic sailing here until the next crossing of the heliospheric current sheet. These plasma fields are all pretty jumbled up. We don't expect any extreme magnetism. If you look at the last frame, you see these areas where there's really tight field lines. Those are essentially magnetic sponges. And we won't see any, unless something changes in the corona, we won't see any significant magnetometer spikes until we cross the current sheet. Moving on. Next, how about some magnetosphere movies? Here's the velocity. You can see some choppiness in the solar wind coming in from the left. Those different colored bands representing different velocities of solar wind. You also notice that the density is very high around Earth right now, actually. See the navy blue is the high density and the white is the lowest density. Quite a high density situation here. And lastly, the pressure is actually looking weak, so it's an interesting day for magnetosphere movies. Let that play through for the pressure. And we see the dark side of the planet producing more pressure there than the leading edge, the side facing the solar wind, at the beginning of the movie at least. Next, we'll look at geospace magnetic perturbations here. First, looking at the poles. Some pulsations happening there. And let's see how that translates over the globe. We would expect to see pulses out Australia, Indian Ocean, and centered on Hawaii. Let's see what happens. There's the Indian Ocean type pulses. Not a lot going on from the North American perspective this time. The Pacific looks magnetically quiet. Next, we'll look at quakes.globalincidentmap.com. Notice a little global downtick in earthquake activity. Although we do have a deep quake at a 4.1 magnitude in Alaska. Looks like it's out in the Aleutian Islands. Way out at the end of the chain where we've been seeing activity. That area should remain on alert for a 5, but I don't think there's anybody there, folks. Also, Chile gets a 4.1 at depth. Looks like right on the coast, which is right in the earthquake watch areas that we've listed. And a bunch of minor quakes in California. 5.4 in the southwest Indian Ridge was the largest quake over this time period. Way out there east of South Africa. And no other quakes of note. By the way, if you are concerned about the deadliest threat associated with earthquakes, it would be tsunamis. So if you ever see one in your area, or if you're worried about somebody being exposed to a tsunami, head to tsunami.gov. It's not a perfect system, but it's pretty much the worldwide source. Check out volcanoes, volcanodiscovery.com. Kluchevskoy is now erupting again, emitting a 16,000-foot ash plume. Shivaluch relaxing a little bit, only a 12,000-foot ash plume now. Sakurajima exploded. 6,000-foot ash plume reported. Popocatépetl, occasional emissions. Fuego, occasional emissions. Reventador, an uptick there, producing a 15,000-foot ash plume. And Sabancaya, we just don't know. Next, we're going to do a segment on the Zooniverse.org, the Galaxy Zoo. If you're not familiar with what it is, head to Zooniverse.org. You can do some actual astronomy here. If you put in your name and create a login, you may be actually cited in a scientific paper. This is an effort to classify galaxies. There's too many hundreds of billions of galaxies in the visible universe to use computers to classify them all. Some of them need visual analysis, and that's where you come in. So head to Zooniverse.org, classify some galaxies, like this one, which has got features or a disk. Is it an edge-on disk? Not really. Is there a bar? No bar to be seen. Is there any sign of a spiral arm pattern? Gonna say no. Is there a bulge? Yeah, there's a bulge. Moderate bulge. Is it merging or disturbed? I think that's actually overlapping there, folks. We're going to say no disturbance. And I believe this object here is actually a foreground object, so we're just going to say overlapping. Done. We just classified a galaxy. How about Science Alert? ScienceAlert.com. Rare asteroid spotted orbiting the sun closer than Venus. It's a pretty rare thing to see. This one is called 2019 AQ3, an asteroid whose tight elliptical orbit is nearly always closer to the sun than Venus and even dips closer than Mercury. It takes just 165 days to orbit the sun. The shortest year ever seen in a solar system asteroid. So that's a pretty rare thing. It's just discovered on January 4th, 2019. We'll leave links to the article. Here's one from SciTech Daily. Scientists show sun's magnetic waves behave differently than believed. We'll leave links to this article also. This one is talking about how sound waves coming out of the sun seem to affect the magnetic environment. Next, we got one from Cosmos. Dark matter may not actually exist. Physicists suggests telltale alternative. That's great writing there. It's great writing, Cosmos magazine. Well done. So in any case, this article is about how we don't find any dark matter and how dark matter was created in order to explain electromagnetic fields which control galactic level motions. So pretty much what the article is about is just modifying gravity and a fundamental misunderstanding of astrophysics. Have yourself a read if you like. Next, we got a phys.org article. How do you like your stars? With salt, please. Liberal sprinkling of salt discovered around a young star. That's an artist's rendition, by the way. Orion Source 1, a young massive star about 1,500 light years away. ALMA observations detected a ring of salt, sodium chloride. That's right, ordinary table salt. It's the first time we've ever detected that around a young star. People thought you couldn't get molecules like that, what we call in astronomy metals, everything besides hydrogen and helium, around a young star. And there you have it. Salty star. We'll leave links to that article as well. And next we got a theory in the comments section from our pre-1000 subscriber special here by Anomalous Howard. Here's a theory about when the Earth's pole flip happens. So, I'm just going to read this aloud. So, leaving aside the composition of the Earth's core, it has been found there's a differential rate of rotation at the outer core surface. So, the differential flow rate on the sun's surface does this to its magnetic field lines. Show you that link. So, you can see as time goes on, the rotation of the outer portion switches versus the inner portion. The field lines change. The sun's poles flip. Now, this has been my theory, that the solar polar flip has to do with the Earth's pole flip, and that the Earth's pole flip is most likely to happen during a solar pole flip, which is supposed to happen during every solar cycle. Without getting too much into the weeds on that, let's go back to the comment. That leads to the magnetic pole reversal of the sun every 11-ish years. The equatorial surface of the sun completes a rotation in about 27 days. That's called the Carrington rotation. The faster portion of the surface of the Earth's outer core has tripled in speed in the years between 2000 and 2016 to about 42 kilometers per year, from about 14 in 2000. So, in other words, the Earth's proportional Carrington rotation has gone from 776 years, according to Howard, to 592 years. So the degree to which differential rotation changes the Earth's magnetic field lines, the way that happens to the sun, is much slower, but it's speeding up. The stretching and distortion of the field lines from a north-south orientation to a more east-west orientation leads to both the magnetic pole flip and a weaker magnetosphere. The flow at the outer core has been accelerating. The pole shift and weakening of the magnetosphere has been accelerating. It's the Earth pole flip explained. You heard it first here, perhaps, unless you read our comments, in which case you heard it before I read it. This is about 2 days old here. But in any case, that is an interesting theory. Now, I don't believe in the iron-nickel core of the Earth. I don't think that's necessary. I think it's just made out of condensed matter. Something like liquid metallic hydrogen and solid-state hydrogen inside of that, which is enough to create the fields. Remember, all you need is a magnet moving through a magnetic field. But this is a very interesting comment here, and I guess I'll leave links to this video so you can read the comments and possibly comment yourself. Lastly, I would like to look at something that we noticed yesterday in the new Thunderbolts project video. If you didn't see that, look at yesterday's video description. What you're looking at here is the 30 gigahertz sky in polarization. That's the Milky Way galaxy, folks. So, just let that sink in. We'll leave links, but I would just have you note these curved features here, which are going right across the plane of the galaxy three-dimensionally. You think those are caused by gravitational accretion? Just putting the question out there. Yeah. That's not from gravity, folks. And boy, oh boy, is that thing ever oblong. Look at the Cygnus arm. I mean, man, the Milky Way is pretty irregular. Now remember, when you're studying astronomy, as physics is getting rewritten, don't drink. And if you drink, watch physics get rewritten. And don't drive.